Have you ever looked in a mirror? You see yourself because of light. Light bounces off the mirror and into your eyes. This is reflection. Now imagine a straw in a glass of water. The straw appears bent at the water's surface. This illusion happens because light changes direction when it passes from air to water. This bending of light is called refraction. Light is fascinating. It travels incredibly fast. Light can act like a wave or a particle. Understanding how light behaves helps us understand our universe. Reflection and refraction are fundamental properties of light. These phenomena explain how we see the world around us. They are also essential for many technologies we use every day. Reflection is the bouncing back of light when it hits a surface. Think of a ball bouncing off a wall. Light behaves similarly when it encounters a smooth surface like a mirror. The law of reflection explains this behavior. It states that the angle at which light hits a surface, the angle of incidence, is equal to the angle at which it bounces off, the angle of reflection. This means if light hits a mirror at a 30-degree angle, it will reflect at a 30-degree angle. Mirrors are the most common examples of reflection, but reflection happens all around us. We see objects because they reflect light into our eyes. Smooth surfaces like mirrors reflect light in a predictable way. Rough surfaces scatter light in many directions. This scattered reflection is why we see objects from various angles. Refraction is the bending of light as it passes from one medium to another. Light travels at different speeds in different mediums. For example, light travels slower in water than in air. When light passes from air to water, it slows down and bends towards the normal. The normal is an imaginary line perpendicular to the surface. Similarly, when light passes from water to air, it speeds up and bends away from the normal. This bending of light is responsible for many optical illusions. A straw in a glass of water appears bent because light from the straw refracts at the air-water boundary. Our eyes perceive the light as coming from a different direction, making the straw appear broken. Refraction also explains why objects appear larger or smaller when submerged in water. The light from the object bends as it passes from water to air, making the object appear distorted. The principles of reflection and refraction are used in many optical devices. Lenses used in eyeglasses and cameras use refraction to focus light. A convex lens converges light to a point while a concave lens diverges light. Periscopes used in submarines use reflection to allow us to see around corners. Light enters the periscope and reflects off two mirrors positioned at 45-degree angles. This reflection redirects the light to the viewer's eye, allowing them to see what is above the surface. Magnifying glasses, used to enlarge small objects, use a convex lens to converge light and create a magnified image. The lens bends light rays so that they converge at a point behind the lens. This creates a virtual image that appears larger than the actual object. Understanding reflection and refraction has led to countless technological advancements. From eyeglasses that correct vision to telescopes that allow us to explore the cosmos, these fundamental properties of light play a crucial role in our lives.